we ready? Everything in here is brand spanking new. Well, not all brand spanking new, but some is review. It starts off today as review. All right, so first things first. We're going to hit 12.1 right now, and this is review. So 12.1. So we're going to talk about two equations, two unknowns first. Actually, I do it this way, because we're going to talk about three equations, three unknowns soon enough. So when there is two lines, since we're talking about linear equations, since there's two lines, three things can happen. One is that they can intersect each other at one point called x comma y, and which means that if we find x, we have to find y. Okay? The other situation is the two lines could be parallel, and they never touch each other. In this case, it's no solution. And we know that, yes? This is where x and y disappears, and you'll only have left numbers. And you'll get numbers like 0 is equal to 5, which is a false statement. So anytime you get a false statement, it means that there's no solution. And third is if the two lines are on top of each other. That means they intersect all the time. So this is infinite number of solutions. Same thing happens here. X and y disappears. However, you get statements like this, 0 equals 0, which is a true statement. You guys remember that, yes? And of course, with this being said, there's two methods that we use. Do you guys remember those two methods? Mm-hmm. We use substitution, or we use elimination, which is also known as addition method. So let's say we use an example just to run through it. X plus 3y equals negative 4, and 2x plus 5y equals negative 5. If we were to use substitution, what we would do is we're looking for a coefficient of 1 or negative 1, which we see here. And what we would do is, from that, we would isolate that x, or that variable that has a coefficient of 1, -1. And what we would do is then take that equation or take that x value and then substitute into the other equation. That is what is known as substitution. Taking one equation, substitute it into the other. So I'll have 2 times that x plus 5y equals -5. And then solve. So when we're solving here, we get -6y plus 8 plus 5y equals -5. Negative y is equal to negative, whoa, sorry, made a mistake here. There we go. It's supposed to be -6y minus 8. So we're going to get negative y equals 3. Oops. So y is equal to -3. So with that being said, since I found a y, and this is where you would figure out the no solution and infinite number of solutions, right? Since I found a y, that means there has to be a corresponding x to it, right? This is where the x and y would disappear, and then you have just numbers, hence you have one or the other. Okay? So from here, you can always take this and substitute it back in here to find your x value. That's pretty much review. Now with substitution, with elimination or addition method, this is where you choose if you want to eliminate x or eliminate y. You get to choose. But bottom line is that you have to have the coefficient to be additive inverses. Okay? I want to do the difficult version because there is times where you have to only multiply one to get them to be additive inverse. Sometimes you have to multiply both. Okay? So you could multiply the top equation by -2. You have -2x and positive 2x, which that will eliminate. But I'm going to do it this way instead. So I'm going to go ahead and multiply the top by a -5 and the bottom by a +3. The reason why I chose that is because if I multiply this -5 by this +3, I get a -15. While I multiply this 3 with this 5, I get a +15. So -15y, +15y will eliminate the y. Okay? So I will rewrite this. So I get -5x minus 15y is equal to 20. Distribute a 3 in, I get 6x plus 15y is equal to -15. And the reason why it's also called addition is because we add those together so that we get x is equal to 5. Same thing, you can take that x, put it back into one of the equations, and solve for y. My favorite is to do a double elimination. Since we just eliminated y, go back and eliminate x and solve for y. That's my favorite myself. But it can't always, well, with substitution, you can't do double substitution, but you can do double elimination. Are we okay here? So far, pretty much a review. Right? I could also type these two equations into the graphing calculator, and it'll intersect at 5, -3 as well. Okay? Any questions there? Nothing? Okay. So we also have something called 3 equations, 3 unknowns. So the thing that you have to realize is that however many unknowns we have to have the same amount of equations. So if we have 3 unknowns, x, y, z, a, b, c, we have to have 3 equations in order to solve it. Right? So one of the harder ones is when they ask you to find, let's say, quadratic function, and they'll tell you it's y is equal to ax squared plus bx plus c. And then they'll say, hey, just so you know, when x is 1, it's going to equal to 269. When x is equal to 3, is equal to 211. And when x equal 4, y is equal to 134. Right? Okay. Well, since I have an x and y here, what I can do is I can plug that into the quadratic function. So y is going to equal to 269 when x is equal to 1. So a times 1 squared plus b times 1 plus c. And I can do the same thing with the 3 to 11. It's 211 when a times 3 squared plus b times 3 plus c. And last but not least, with the 4. So then I can say, oh, 134 is equal to a times 4 squared plus b times 4 plus c. Do we know where all those came from? Yes? Awesome. So let me rewrite these equations here. I have 269 is equal to a plus b plus c. I have 211 is equal to 9a plus 3b plus c. And I have 134 is equal to 16a plus 4b plus c. So I'm teaching you how to do this the long way right now. In 12.2, 12.3, I'm going to teach you how to do it the other way, which is matrices. Some of you guys understand matrices. Some of you guys have no idea what that word even means, and it's okay. It's a lot to learn. So to do this, we typically number these. Equation 1, equation 2, equation 3. And we got to pick 2 pairs and eliminate the same exact variable. So pick 2 pairs of equation and eliminate the same variable. In this case, the easiest variable to eliminate is c. So let's say out of the laziness of myself, I'm going to go ahead and pick 1 and 2. And I'm going to go ahead and pick 2 and 3. And I'm going to eliminate C here on both of these. To eliminate these, I'm just going to go ahead and distribute through a negative through the top. Also through the top here. My equation 1 is now a negative 269 is equal to negative A minus B minus C. And over here, obviously you don't have to do this simultaneously like I am right now. Negative 211 is equal to negative 9A minus 3B minus C. And the reason why we're doing this is because what this forces us to do is to eliminate one of the variables so that we're down to 2 unknowns. But we're also going to have left 2 equations, equation 4 and equation 5. What is this, negative 58? Is that right? Someone check my math. What is this, 77? Someone check my math there as well. Is that negative 77? Yeah. Is equal to, what is this, 7A plus B. So now, as you guys can see, I have 2 equations, 2 unknowns. And typically with these equations, you guys don't have to worry about specifying if you're doing elimination or substitution. And the reason for it is because it's way too hard to force you guys to go in that route. If it's 2 equations, 2 unknowns, you got to be careful because it might tell you to do substitution. It might tell you to do elimination. So you have to show it that way in the lab work. But here, with 3 equations, 3 unknowns, it doesn't usually specify for you. Any question on how I did any of this so far? So far, so good? No questions? All right. So here it looks like the easiest thing to do is eliminate B. So I'm going to go ahead and multiply this 5th equation by negative 2. So equation 4 stays the same. However, my equation 5 now becomes a, what is that, 154. Check my math, negative 14A minus 2B. And when I add those 2 together, what is that, 90, 96? $16. So we're going really from 3 equations down to 2 equations down to a known. Then we can go backwards to now 2 knowns and then to 3 knowns. Right? So from here we're going back up. So essentially, I can take this A and plug it into, doesn't really matter, let's say equation 4, just for poops and laughs. So when we do that, we're going to get negative 58 is equal to 8 times negative 16 plus 2b. But say ya ba I sub ya yo. Is that right? Was that 123? 133? Oh. More. Oh, because I had 58. Dum-dum. Yeah, that changes. Negative 70? Yeah? Oh, so it's positive 70. Is that what you're telling me? Yeah. Okay, thank you. So B is going to equal to 35. Now I can take B and the A and plug it into equation 1. What did I make equation 1? Red. Equation 1 was 269. So I got 269 is equal to A plus 35 plus C. So C should come out to be, I think, 250. So then I have my equation. Y is equal to negative 16 x squared plus 35x plus 250. What's another way of doing this without matrices? Don't say graphing, because it won't come out. Because on the graphing calculator, we only see x and y. It's something we already learned. Quadratic. Nope. The first word is right. It's about the second word. Nope. Starts with an R. Regression. Do we remember what quadratic regression is? Let's do a reminder here. Remember when we did this, make a table. What was it? 1, 3, 4. This was 269, 211, and 134, right? Then we say y1 is approximately ax squared. Oh, sorry. Oh. 1 squared plus b x1 plus c. You guys remember doing that? We did it for quadratic. We did it for cubic, logarithmic, exponential, and linear. Okay, doke. And our A, B's, and C's came out correct, right? Any questions there? All right. Let's get into the new stuff. The stuff that you're going to love. Now, I don't know why I didn't do that for 12.2, but 12.2 was supposed to have a blank notes as well. So everything from here on out should have some blank notes. I didn't put that link on there, did I? For 12.2. All right. So 12.2. Matrices. What the heck is a matrices? Oh, wait a minute. Let me do it this way instead of me writing everything out, because I know I'm not going to want to write everything out. 12.2. There we go. What is a matrix? It's a rectangular array made up of rows and columns. Rows are going from left to right. Columns are up and down. You saw the blank for 12.2, though. 12.3, I mean. Okay. So a 2 by 3 matrix, the first number is the rows, second number is going to be your columns. So it's row by column. So it's 2 rows and 3 columns. So 2 rows and 3 columns will look like this. I'll give you guys some time. There's a lot to write and try to remember at the same time. So when I say 2 by 3, 2 rows, 3 columns. And typically when I hear the 2 by 3, I make sure I make a box. That's a 2 by 3 right off the bat. Okay? Rows go from left to right. Columns go up and down. Right. So let me give you guys some good news, bad news. Ready for good news, bad news? Good news is the TI-84 has a matrix calculator. Bad news, Desmos does not. Good news, it don't really matter. Doesn't help you, nor does it hurt you. Okay? Because on the exam, on the lab work, you got to show all your work anyways. So the matrix calculator helps jack squat. On the exam, I'm going to be giving things that are so simple that having the calculator and not having the calculator really is not an advantage. Okay? And on the final, having the matrix calculator does not help you whatsoever. You will see that in the optional lab work. Okay? So, when we label each element in the matrix, when we label each element in the matrix, notice that the subscript is row first, then column. So A11 would be the element in row 1, column 1. A12 is the element in row 1, column 2. Row 1, column 3. row 2, column 1, row 2, column 2, row 2, column 3. So how we name the matrix row by column is also how we name the elements row then the column. We okay there so far? So how we would use matrices to solve system of equations is that if you notice here on the right side, the columns, I got the x column, the y column, and the answer column. So the coefficients of the x, I should back up here. Back up before I say that. So I should just say rewind, play. So number one, when you write your equations, make sure they're in standard form. All the x, y's, z's are on the left side, and the constants are on the right side as the answers. Okay? That's number one. Then what I would do is take the coefficient and put it under the correct columns. So since I have x, y, then the answer, my first row would be 3, 4, -1. My second row would be 7, 8, -2. So obviously you guys don't know what this word row operations mean, but with row operations we can either do row echelon form, which in your calculator will be labeled as REF, or reduced row echelon form, RREF. Okay? So what's the difference between the two? Don't worry, we'll talk about row operation soon enough. And don't worry, you'll get into the mess soon enough. And the headache soon enough. The migraines soon enough. Okay? So let's talk about what row echelon form versus reduced row echelon form. So in your calculator it's called RREF for reduced row echelon form. All right? So row echelon form means this. Means that this major axis, or major diagonal, is all ones. And this bottom left-hand corner is going to be a 0. That is your row echelon form. If it's any bigger, still, your major diagonal are all ones, and everything else to the left of that diagonal is all going to be zeros. Okay? Because obviously this could be bigger. Right? More rows, more columns. But the major diagonal starts on the top left-hand corner and goes diagonal, like a slope of -1. Okay? That major diagonal will be all ones, and everything to the left bottom of it will all be zeros. Okay? That is considered row echelon form. Okay? Reduced row echelon form is where the major diagonal are all ones. Everything else are zeros. So if this was any bigger, all of these would be zeros, or I should say, all of these would be zeros, and all of these would be zeros. Where in the row echelon form, only all of these will be zeros, and then there's going to be numbers over here. Okay? So what's the difference? The reason why they have row echelon form is because most of your work is done, but not completely done. Okay? So after you get done, after you convert, let's say this equation here into a matrices, you get to row echelon form, majority of work is done. So then you got to convert that matrices back to equation form. So if you look at this row right here, right, this means 1x plus 8 over 7y is equal to negative 2 over 7, period. Next row says 0x plus 1y is equal to negative 1/4. That's why you see these written out. So again, most of your work is done, but not completely done. So in row echelon form, I have my y value equals to negative 1/4. However, I haven't found my x yet. That means I have to take this y, plug it into this y, and solve for x. Does that make sense? Okay. In reduced row echelon form is nice because the 1 is underneath the x. This says x plus y plus 0y equals 0. That means my x is equal to 0. This says 0x plus 1y equals negative 1/4. So that means my y value is equal to negative 1/4. So the reduced row echelon form, everything's complete. My work is done. I know my answers. Where row echelon form, again, question is how many steps do you want to take? Right? Row echelon form, less steps, but still work left to be done. Reduced row echelon form, more steps, but your work is completely done. Okay? Any questions so far? We're okay? Not as intimidating? So as I said to you guys before, some of your exam 3 was new, which was the conic sections. In exam 4, everything is new. As you guys can see, matrices, brand new. Right? So here, I'm giving you guys 3 equations, 3 unknowns. I want you, and I'm going to show you guys how to do row operations. But first, let's put this in the matrices. First, what I have to do is get these into standard form. Right? The first one is already in standard form. That's great. I'm going to leave that alone. But if you notice, the second one is really just 2x plus z is equal to 4. The third one is y plus 2z is equal to 7. Everybody agree with that? Now we got to put it into the matrices. So it's going to be a 3, 1, negative 1, 0. 2, 0, 1, 4. 0, 1, 2, 7. I want you guys to go ahead. Obviously, I rewrote this matrices right down here. I want you guys to go ahead and take the next minute or so and please write this down. This is actually in that order. So go ahead and write those down. What our goal of row operations are going to be to get to REF. We're not going to go all the way to REF. I'll show you how we would go about it. But first, let's get into the row operations. So go ahead and take the next couple of minutes, write down the goals so I can explain it to you what I mean by all these different things. A lot. All these different colors, man. How are we going to do this? Take your time. I'll wait. Okay, so let's talk about what all of this means. Because it's hard to see when it's written out this way. Very hard to understand. So, here is what we're actually doing. So step 1 and 2 is essentially trying to do this. We're trying to make this a 1. Actually, let me use red. We're trying to make this a 1, then make this a 0, make this a 0. Okay? Got it? Then we're going to make this a 1 and this a 0. Then we're going to make this a 1. So if you notice, the major diagonal are all 1s, and everything to the bottom left of it is all 0s. Everybody see that? Okay? So if you looked at the 5 steps, those are the ones that we're attacking. Now we're attacking column by column. 1, make it 0, make it 0. Then 1, make it 0. Then 1. If we were to do reduced row echelon form, then this is what we would do. Make this a 1, make this a 0, make this a 0. Then we'll make this a 1, make this a 0, make this a 0. Then we'll make this a 1, make this a 0, make this a 0. That's reduced row echelon form. Notice the major diagonal is all 1s. Everything else is 0s. Got it? And then whatever is the result here, this would be my x, this would be my y, this would be my z. Okay? So that is the difference between row echelon form versus reduced row echelon form. Okay? So I have this all in color. So goal number 1 was to get A11. So when we get something to be a 1, the easiest way to do it is multiply by its negative reciprocal, or multiplicative inverse of it, right? Or actually not multiplicative, just the reciprocal. So to make a 3 a 1, we just have to multiply by 1/3. So if you notice, the way we read this is this. The new row 1 is going to be 1/3 times the old row 1. So again, the new row 1 is equal to 1/3 times the old row 1. So when we multiply, we have to multiply the whole row. So if you notice here, multiply by 1/3, multiply by 1/3, multiply by 1/3. And then we lay down the results. Are we okay so far? Just like if we were doing elimination, right? If we multiply by a number, we're going to multiply every single term by the number. And again, guys, at home, feel free to unmute yourself and say, whoa, 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 talk to me here. I'm confused about yay, I'm confused about nay, okay? Feel free to do that. Or even tell me to pause. I need 2 minutes to write this. Fine, no big deal. I made this a 1. Step 1 is complete. Is that true? Accomplished. I hit my goal. I completed step 1. Woo! Next goal is to make this 0. So the reason why we made this a 1 is because it's very easy to make this a 0. Because if you think about elimination, right? The whole purpose of elimination is to make sure that the coefficient was the same number but opposite signs, right? So when we added, it becomes 0. Same exact idea. With 1, I can multiply by anything, right? But I got to make the 2 a 0. How do I make a 2 a 0 with a 1? Multiply by? If I multiply 1 by 0 and add it to 2, how does the 2 become 0? So let me write this out. This 1 plus something, I'm sorry, 1, this 1 times what, question mark, plus 2, this 2 here, would equal to 0. It would be negative 2. Make sense? Okay. Yes? So essentially 1 times a negative 2 plus 2 would give me 0. Right? So step 2 was to make this a 0 and this a 0. Well, good news is that this is already a 0. So I got to make that a 0. So in order to do that, I want to take the new row 2 is going to be negative 2 times the old row, well, actually it's a new row 1, right, plus row 2. So I have to write these formulas down. So this is now my new matrices, or matrix, okay? So I got to take that 1, which is in row 1, multiply by negative 2, and add to row 2 to get rid of that 2. Okay? I know it sounds confusing, but here it is. So I'm taking negative 2, multiply by row 1, plus the old row 2, which was a 2 right here. Now, the question is, do you need to show all of this math in your lab work? No. This has to be right, though. You don't have to show all of this work. I'm only showing this work for your sake. Okay? Do we know where those numbers are coming from? The black numbers in this row right now is all coming from row 2. The pink number is coming from row 1. Don't forget, these notes are already published, right? So you can always go back to it, and it's going to get published again with this recording, so you can go back to it again. Okay. Do we know where all these numbers are coming from? We're okay. Yes? So when I do the math, I should get what you see on the right as a matrix. So you should see this. Or I should say, when you do this math, you should get 0. If you do this math, you should get negative 2/3. When you do this math, you should get 5/3. And when you do this math, you should get 4. Yes? When we made it to standard form. Because we had to move it to the other side. Okie doke? So really, step 2 and step 3 is accomplished, right? Because this was already a 0. So we didn't really have to make it a 0, right? If we needed to, if that wasn't a 0, then we'll have to use, again, row 1 to help us make that a 0. Is that fair? Okay. So we now have 1, 0, 0. Whew, done. Now we have to make this a 1. Now, some of you guys might say, so does that mean we got to multiply by negative 3/2? You could, but we already have a 1 here. So I could swap row 2 and row 3. So that's all we're going to do. We're going to swap it so that that becomes 1. That is 1. Right? So we made equation 3 equation 2 and equation 2 equation 3. No big deal. Luckily, for the x side of it, they're both zeros. Right? Because if one of them was a 1 and we swap it, now we got to force that to be 0 again and the other one back to a 1. Then that'd be ugly. Okay? So it's like the Rubik's Cube where we're trying to keep this the same while getting the other, this to be a 1. Right? Because a lot of times you get one side done, you're like, woohoo! And you go get the other side done, and you go, oh, crap. The other side just got screwed up. Right? So somehow you got to keep one side done while making the other side go. All right. So now I got to make this a 0, don't I? So how do I use 1 to make this 0? I guess I kind of gave it away, huh? So if I multiply this 1 by a positive 2/3 and add to a negative 2/3, it would become 0. So that's what this equation is right here. Take the row 3. It's going to be 2/3 times row 2 plus row 3. So here's the math right here. Again, I'm just showing it. You guys don't need to show that part on the lab work. You just got to get that equation correct. Make sure that you know exactly where these numbers are coming from. Because that's where you're going to get confused about is where are these numbers coming from. Do we have questions about the equation itself? This is why we always get the 1s first before we get to the 0s. We never try to get the 0s first and then get to the 1. Always the 1s before we get to the 0. We understand where all the numbers are coming from? Okay? We're good? At home, any questions? No questions. We're good. All right. Now, our last thing is to make this a 1. How do I make a 3 a 1? Multiply by 1/3. And that's exactly what this is saying. My new row 3 is 1/3 times row 3. So here is where the question comes into play, right? Do we go to reduced row echelon form, or do we stop here, right? So reduced row echelon form just has 3 extra steps. Where before you do this last step, you'll make this a 0. And after you make this a 1, you make these 2 zeros. So it's just 3 extra steps. 3 extra operations, and you have all the answer. Right? Where here, we don't have all the answers yet. We only know one answer. That z is equal to 26/9. We have y plus 2z equals 7. And we have x plus 1/3 y minus 1/3 z is equal to 0. Those are the 3 equations that we have. But since we have z, we can plug z into here and solve for y. And then we can plug this y and the z in to solve for x. So the question is, would you rather do this or would you rather do reduced row echelon form? That's your call. For me, I'd rather do the 3 extra because I'm already in that mindset of how to get those zeros. So I would just keep on going. Instead of getting my brain to switch back to solving equations and solving those equations. But that's just me. How are we doing with all of this?
So basically what I'm getting is that you're changing one formula so that you're getting what the goals in the steps are.
Say that again.
So what I'm getting is that you're changing one equation at a time in order to get the goals we need for REF.
Yes.
Okay.
Yeah. Yeah. But they're working with each other as well, right? So essentially, I'm using elimination to try to make this happen. Okay? So here's the upside of matrices, because you're like, wait a minute, dude, we've done 3 equations, 3 unknowns. We were happy with our method. Why this? Why confuse us? And the reason is because this is the really simple stuff. Because if it was 4 equation 4 unknowns, 5 equation 5 unknowns, 9 equation 9 unknowns, now we're going to have a headache. Does that make sense? Where the matrices takes care of that much easier. And your question?
So it's basically, the matrices is just like a tool to solve like 6 different things at once.
Correct. Correct. It makes it a little bit easier with these row operations. Because if you notice that as we went through, right, we involved parts of the other equation to manipulate our ones and zeros. Right? So we got a chance to pick and choose which ones we used. Right? When we did 3 equations, 3 unknowns, we were like, okay, pick 2 pairs. Now we got 2 equations, 2 unknowns, and then solve, boom, boom, boom. But what if it's 4? Ugh. I don't even want to think about doing 4 equations, 4 unknowns. Right? Now do I have to pick like 3 pairs to get the 3 equations, 3 unknowns, and then go from there?
So would it matter which order the equations are in? And it's like for the any of the forms, theoretically you could have a 1 in the second column by first row, or does it? And then as long as there's at least an x, y, and z value that you can find, theoretically, doesn't matter if there's a diagonal or not?
It does. Because of the reason why we want this diagonal to be a 1 is because this is my x, this is my y, this is my z.
Okay.
Right?
Right. So you need that diagonal there because if it changes, then okay.
It would change the equations.
Okay.
Right? So let's give you guys a chance. So I wrote this in standard form. There it is. There's my matrices. Do you guys want to try to go ahead and see if you guys can do, oh, this is reduced row echelon form. So that means I want to get this a 1, this a 0. This a 1, then this a 0. Everybody see that? So this is already a 1, which is great. So we just got to get this a 0, and then make this a 1, and then make this a 0. So you guys want to try to do that with this one? See if you guys can do it with the row operations. And then this way, when you're doing it on your own, you'll be like, okay, now I got questions. Wasn't Nellie from LA? Is that what she was dressing as? Nellie? Do you guys even know who Nellie is? The rapper Nelly? Like Country Grammar Nelly? Okay. I thought you were from LA. So we got to use that 1 to make the 2 a 0. So what do we multiply 1 by to make the 2 0? What do we multiply 1 by? Added the 2 will make it 0. Nope. Say that louder. Negative 2. So that's what you're going to do. You're going to say the new row 2 is going to be negative 2 times row 1 plus row 2. Except the multiplying that the number that you're multiplying by might be different. Because that's the whole purpose of me getting this to be a 1, is so that I can multiply by whatever to make and add it to that to make it 0. If that was a 3, then I'll multiply by -3. It just happens to be where the first example, this was a 2 as well. That's why it was -2. Right? And when you try it, you'll see that if this doesn't turn into 0, then your equation is no good. Does that make sense? Yeah. Right? If you were to use 0, let's say, right? You say, okay, 0 times row 1 plus row 2. And when you write that out and you do it, and you're like, this doesn't become 0. You're like, something's wrong with the equation then. Because to me, it would be like this, right? It will be, okay, so what times 1 plus 2 would give me 0, right? And if the answer is -2, okay, so it would be -2. Where did 1 come from? 1 come from row 1 plus where did 2 come from? Came from row 2. Right? So that's going to be my new row 2. You guys need to ask your questions that you need to ask, whatever it might be. You're stuck somewhere. Where are you stuck on?
I'm just thinking.
What are you thinking?
Like, I'm just trying to fully grasp it.
Explain. Tell me more.
Like, comparing it to, like, the steps you took in the 3 row.
Yeah? What about it?
So did you, like, just use, like, a similar formula for each row? Or just based on, like, the numbers there?
It's going to be based on the numbers.
Yeah.
It has to be based on the numbers.
All right.
Like here, if this was a 3, all right, yeah, no, let's do this. If this was a 3, right? Then, again, I ask you, what times 1 plus 3 gives you 0? So you go, okay, it's a -3. So you go, okay, -3. Where did the 1 come from? Came from row 1. Where did the 3 come from? There's my equation. Because all of these numbers are coming from this right here. I'm using this 1 to make that a 0. And then whatever happens along the way, it happens. But my goal is to make that a 0. Everything else is going to change based on that. Yes?
So for getting row 1, column 0,
Yep.
we can't just ignore row 1, column 1. So I don't. How do we get the -4 to 0 without impacting the first number?
Well, remember, the first thing you got to do is make that -6 a 1 first. And because you make that -6 a 1 first, it won't impact it. That's why we always focus on the 1 first and then do the zeros. Ask your questions, guys. So, yeah, we got to make that a 1 first. So how do you make that a 1? Times row 2. Mm-hmm. 1. Mm-hmm. Now you make that a 0. How do you make that a 0? 1, right?
I don't understand how we use the 1 from this equation to make this a 0.
Well, what times 1 plus a -4 will give you 0?
4.
Mm-hmm.
I'm still concerned about the 1 right here.
Go do the process. Plus row 1. Because notice this, you're doing 4 times 0 plus 1, which is still 1, right? No, you're fine. That was right. 4 times row 2 plus row 1. Okay. Now, go through it. You're fine. That was fine. Now draw your matrices. So you have row 1, so 1 is, right? Row 1 is equal to keep on going. How do you make that -4 goes to 0 with that 1? You're just going to copy what I have down.
Like that. So you have to make it a half.
Mm-hmm.
Because you have to make it equal to 1, so you multiply it.
By 1/2, yeah. So that's going to be
be
1.
1 and 3 and 1.
Yeah.
So then,
Then you got to make that a 0.
oh, you have to make that a 0 too.
Yep. Huh?
'Cause you have to,
Yep. 1 times what plus -4 equals 0? You okay with everything? Are you seeing it or no? Right? Didn't affect it at all.
Okay.
Look at that.
It's just the numbers get all mixed up in my head.
Yep. Now, guys, don't get me wrong. Do I find writing this out make it helpful? Absolutely. I find it calming my mind. Right? Because every single time that formula goes, I'm using different numbers. Right? Like over here, I got to pick the 0 and the 1. Over here, I got to pick the 1 and the -4. And over here, I got to pick the 3 and the 1. Right? So I find that writing it out makes it easier on my mind. Calms me down. But this is what it's supposed to look like. Does it make sense? It seems like you're catching on a little better, making more sense of it. But again, I'm always going to try to get the 1 on the diagonal axis, or diagonal first, then make the zeros happen. Make the 1, make the zeros happen. Make the 1, make the zeros happen. Is there any questions at home about this? We're good. Are we sure? No questions. Ask it. That's what I'm here for. So maybe a good idea is to open up the lab work and do some of the matrices. So that when you guys come back, you're like, help me. Here are some of my questions now. Right? Now, 12.3 is going to be a lot, not a lot of fun at all. So here's something I'm going to tell you about 12.3. I would tell you to open up those notes before you come in. There's a lot of highlighting here. A lot of colors. Because we're talking about determinants, and we're going to be talking about Cramer's rule. So 2 by 2 isn't bad. It's the 3 by 3 that's going to get bad. So before I let you guys go, just so you guys know, that I want you guys to see that this, right, came from when I double highlight what is double highlighted. And this box right here is what's left here. Okay? This is what's double highlighted. What's here in this box is here in this box. What's here is double highlighted here, and what's in this box is left in this box. Okay? And as we go, that's going to be very scary. Very, very scary. Okay? So as we go, things are going to, so this is going to be an ugly, ugly, ugly chapter. Or ugly week. All right? So ladies and gentlemen, please have a wonderful, blessed day. Please be safe. Love you guys. Now that I scared the crap out of you guys, have a wonderful, blessed day. See you guys on Thursday.